Hello, my amazing students. This is Mrs. A, and we are talking about 6.2, which is more about exponents and scientific notation tonight. So here's our first problem, and notice that it's kind of a hodgepodge of some of the things that we've already worked on. And on this first part here, we have a product, and that product includes a power that's raised to another power. So basically, we're going to have 4 squared p to the negative 8 squared times 2 cubed p to the 4 cubed. Okay, so now we're going to take each part of this long expression and start simplifying it. Let's see if I can get that glare off the board. Okay, so now we've got 4 squared, which is 16. And p to the negative 8 squared is going to be p. Remember, when I raise a power to another power, I multiply, which will be negative 16. 2 cubed is 8. And then our p to the 4th raised to the 3rd power is p to the 12. So now I'm going to multiply the 16 times the 8. And I'm going to figure out what that is in a minute. And then I'm going to multiply the p's together. And when I multiply, I add their exponents, which will give me a p to the negative 4. Okay, so now we need to clean that up a little bit. Our 16 times our 8 is going to give me 48, carry the 4, 128. Okay, so this right here is going to become 128, and the p to the 4 is going to go downstairs because it has a negative exponent. So the p to the negative 4 is going to go downstairs, and this will be my final answer. All right, our next problem, it has a bunch of k's in it, and we're going to multiply the ones in the numerator, which will be k. And remember, I add the 2 exponents, one's positive and one's negative, so that's going to give me a k cubed on the top and my k to the 7 on the bottom. And then my k cubed and my k to the 7, when I'm dividing, I subtract the exponents and I get k to the 3 minus 7, which is negative 4. And then lastly, I need to move my k to the negative 4 downstairs, and it becomes 1 over k to the 4. All right, so now we have a big quotient raised to the 4th power, but notice that each part of the quotient is a series of products here. So we've got 2 and 1 on the bottom. Remember, there's nothing there, so that's a 1. And I'm going to simplify what's inside first and then raise the whole thing to the 4th power. So I'm going to have a 2 inside. And my c to the 9 and my c squared, when I divide, I subtract the exponent, so I get a c to the 7 and a d to the 11, take away 5, which is 6. And now I'm going to raise all of that to the 4th power. So that means that I'm going to take each part of the product here and raise it to the 4th power, which, let's see if I got room to write it, is going to be 2 to the 4th. And c, remember, raising a power to another power, I multiply. So I get c to the 28 and d to the 24. Out of room. And 2 to the 4th is 16. So my final answer is 16, c to the 28, and d to the 24. All right, so there's our answer there at the bottom. Okay, on this one, we have a negative exponent overall. And instead of trying to keep track of all of these things, I'm going to flip the entire quotient over. And then I'm going to do what's inside the parenthesis, and then I'll raise it to the second power. Okay, so I don't have to do it in that order, but that's what I'm going to do this time. So remember, our rule is that if we have a over b raised to the negative n, that is the same thing as b over a raised to the positive n. So that's the rule that we're going to be using. So now we're going to just flip the whole thing over and get 25 a to the negative 4 b cubed over 60 a to the 7 b to the negative 1. Now it's going to be raised to the positive 2 there. Okay, so now we've got to clean up what's inside the parenthesis, and I can reduce both the top and the bottom by 5. And when I do, I'm going to get 5 over 12, because 25 divided by 5 is 5, and 60 divided by 5 is 12. When I divide my a's here, I'm going to subtract their exponents, which means that I'm going to get a to the negative 4 take away 7, which is going to be negative 11, and then b to the 3 minus a negative 1, and 3 minus a negative 1 is 4, so I'm going to get a b to the 4 over there, and then I've got to take this whole thing and raise it to the 2, which I'm going to do on a separate screen. All right, so now I have a little bit more room, and we're going to raise each part to the second power, and we're going to say 5/12 squared a to the negative 11 squared and b to the 4 squared. And this one is going to be 25 over 144 and a to the negative 22 and b to the 8. But I can clean that up by putting things on the denominator that need to be on the denominator. So I'm just going to write this whole thing as, I'm going to write it up here, 25 b to the 8 over 144 a to the 22. So there's my answer right there at the top. So basically I'm taking the a to the negative 22 and moving it downstairs, and then taking this fraction and putting one big denominator sign to make it a little bit clearer as to what we're doing. Okay? All right, so now we have some exponents that have variables in them. So we have h raised to the 2a and h raised to the 4a. So we actually have variables inside our exponents. The nice thing is that the rules that we've been using are going to still apply. So we're going to get h, and then we're going to add the two exponents together and get h to the 6a, and that's all we can do. We're done. Okay, so this is the answer. Down the bottom, we have a w, common base of a w, and we have a 3x and an 8x. So since we're dividing, we'll subtract those. So we get w to the 3x minus 8x, which is w to the negative 5x. But we would not leave that upstairs. We would write our final answer here as being 1 over w to the 5x. Okay, so those are some examples of expressions that have exponents with variables in them. So now we're getting ready to start into scientific notation, and we are going to talk about what 10 to a power does to a number. And I showed you in class before that when I was younger, I had to say, okay, I know that 10 to the 1 is 10. 10 to the 2 is 100. 10 to the 3 is 1,000. Okay, so when you're looking at those, the 3 exponent is going to basically multiply by 1,000. And we know that each time we multiply by 10 or divide by 10, we move the decimal 1 place. If we multiply or divide by 100, we move the decimal 2 places. And by 1,000, it's 3 places. So the number of places that are moved are actually the number of zeros that you see or the exponent that you see. Of course, if we're multiplying by a power of 10, we move, our number's getting bigger, so we will move our decimal to the right. If we're dividing by a power of 10, we will move our decimal to the left. So on this one, we are multiplying by 10 to the 5th power. So 10 to the 5th power has got 5 zeros, and it's going to make our number bigger. So we will move our decimal, which is right now here, 5 spaces to the right. So 1, 2, 3, 4, 5. And the new number will be 915.2. Okay, so there's our answer. And then this one, with a -3, we know that 10 to the -3 is the same thing as 1 divided by 10 cubed. And so we're making our number smaller. We're dividing by 10 cubed, and we're going to move our decimal to the left. Notice that this is a times sign right here, and our decimal right now is right here. Our understood decimal is always at the end of the number. So 3, 2, point, we'll write it right there. And then we're moving it 3 to the left. So 1, 2, 3. It's going to go here, and I'm going to fill in. So our new number is, I'm going to take that one away, 0.032. All right, we'll be back with some more. All right, so here are 2 more. We have one with a positive exponent, one with a negative exponent. So the 48 has a decimal point that is currently at the end of the number, but we are multiplying by 10 to the 3rd, which means we're going to move our decimal 3 places to the right. So we'll start with 48, move it 1, 2, 3 places to the right, and our new number is going to be 48,000. Now this one, we have a negative exponent, so that's really 1 over 10 to the 5th, which means we're dividing by 10 to the 5th, which means we're going to move our decimal to the left. So let's write our number here, 2.49, move the decimal 1, 2, 3, 4, 5. Oops, almost out of room. And now, look how small my number is. Okay, so you can see how having something in this notation does make it easier to look at. You don't have to stop and count all those zeros and see how big or small the number is. This form right here is called scientific notation. So, and then this is called your standard form when you're putting a decimal in just a number. So now let's talk about what scientific notation is. All right, here are 2 numbers that are in scientific notation. The rule for scientific notation is that this number in the front is always going to be greater than or equal to 1, but less than 10. So basically, it's got to be a 1-digit number, and that digit cannot be 0. Okay, so 1-digit number, and it can't be 0. So this is scientific. To get it into standard form, we're going to move the decimal 3 places to the right because of this 3 here. So we're going to wind up with 5, 2, 8, 1 with the decimal now over here at the end because we moved it from here 3 steps over. So here we have a number 4.37. We're moving the decimal 2 places to the left to put it into our standard form. So we'll take the old decimal away, our little humps there. So the standard form of the number is 0.0437. All right, so the one on top, we're going to turn this scientific notation into a standard form. Since we have 10 to the 4th power, we're going to move the decimal 4 places to the right. So 1, 2, 3, 4. Move my little time sign. And since I moved past the end of my number, I've got to put a little 0 in. So the standard form is 95660, or 95,660. This number is in standard form, and we are to put it in scientific notation. Because the number in front of the scientific notation should always have only 1 decimal place, we're going to move the decimal right here where this comma is. Right now, the decimal is here at the end of the number. So we're going to count how many steps we need to move the decimal. 1, 2, 3, 4, 5, 6 places to get the decimal here. So 8.1 times 10. Now, 6 is the number. 6 is the magic number that we had to move the decimal place. But are we going to put a positive 6 or a negative 6 right here? The rule is that we always want to have the same number that we started with. We moved the decimal to the left to get our number, this first number, in the correct form. So we moved it to the left, which means we divided by 10 to the 6th. So we will compensate by multiplying by 10 to the 6th. Notice how now this 6, 10 to the 6th, is going to move that decimal right here 6 places back to the right, and I will get back to my original number. All right, so I have a very tiny number here. Remember, decimal review here. This is tenths, hundredths, thousandths, 10,000ths. Okay, so we've got 3 10,000ths here. So very small number. And we're going to turn it into scientific notation. So this is standard form. We're going to scientific notation, which means we're going to have to take the decimal right here after the first non-zero digit. So we're going to go 1, 2, 3, 4 steps. So we know the exponent has a 4 in it, but we moved it to the right to get the proper form of this little number in front. Therefore, my power has got to move it back to the left. Okay, so if we started with the decimal here and we moved the decimal back 4 spaces, we would get back to our original number. So this is the scientific notation for that number. Okay, we're now just talking about how scientific notation can make some operations, multiplication and division operations, easier to do. So here I have 2 numbers in scientific notation, and because of the commutative property of multiplication, I can multiply my constants on the front together, and then I can multiply my 2 bases of 10 together. So 3 times negative 6 is negative 18, and 10 times 10, since we have the same base, we'll add the exponent. So we wind up with 10 to the 5. We're adding those exponents. Now, the problem is this is no longer in scientific notation because the absolute value of this number is no longer between 1 and 10. It's a 2-digit number, so I'm going to have to compensate. Right now my decimal is here. I want to move my decimal 1 to the left. That means I should compensate by moving this one to the right on the number line. So negative 1.8 times 10 to the 6th is the correct scientific notation. Now, they want us to do this also by putting it into standard form, which is going to be negative. Now, I'm going to put 1, and I'm going to move the decimal place 6 places over. So let's put 1.8 real small over here. And let's talk about 1, 2, 3, 4, 5, 6. So since I have 1, 2, 3, 4, 5 spots, I'm going to have 5 zeros. So negative 1, 8, 1, 2, 3, 4, 5. And we can put commas in there to clarify, and that is the correct answer for that one. So both scientific and standard form is correct there. So now we have another multiplication problem. We have 6 times 9 is 54, and we have a 10 to the negative 3 and a 10 to the 4. When we multiply, we add those exponents together, getting 10 to the 1. Now that's not in scientific notation because 54 is not less than 10. So here's my default decimal there. So I'm going to have to move this 1 to the left and move this 1 to the right. So it's going to move from 1 to 2. So 5.4 times 10 squared is the scientific notation. And then to get to the standard form, I'm going to take this decimal right here, move it 2 places to the right, and get 540 is the standard form of that number. 2 more problems. So this one is a division problem. So we're going to divide the whole number portion here and then the powers of 10. So 16 divided by 2 is 8 times, since we're dividing, we subtract the exponents. 10 to the 8 minus 5 is 3. And that is already in scientific notation. It needs no adjustment. To turn it into standard form, we need to remember that my decimal is here. And I'm going to move it 1, 2, 3 places to the right. So it's going to change from there over here with 1, 2, 3 zeros. So 8,000 is the standard form correctly written. And the last problem in 6.2 is this one, where we're dividing 7 and 2, and 7 divided by 2 is 3.5. Okay, this number is in decimal form, as it should be, and then we're subtracting our exponents, so we get 10 to the 4, take away 9 is negative 5, and this is in correct scientific notation. But this is a very small number because that decimal, to get it in standard form, is going to have to move 5 places to the left. So I'm going to move it over here a little bit. So I have some room to move that decimal to the left. 1, 2, 3, 4, 5. And fill in with my zeros to get 0.000035 is the standard form of the number. And that ends 6.2. Remember, tomorrow you will have a quiz on 6.1 and 6.2. This is Mrs. A, and may God bless your day.